What exactly makes the world's most popular operating system run so remarkably fast? To answer that, we aren't just going to sit here and stare at massive blocks of code, right? We need to understand the fundamental drive of the mind behind that code. We really need to look at how a very specific approach to problem solving scales all the way up to global dominance.
Section 1. Linux's unmatched speed, the mindset.
So before we get into the weeds of, CPU cycles and programming languages, we really have to zoom out for a second. Linus Torvalds actually describes himself as old-fashioned, and he has a very specific motivation. As he puts it, I really love hardware. I like interacting with hardware from a software perspective. Now, giving him a soldering iron, by his own admission, would be a notoriously bad idea. But his true passion? It lies in that direct, unadulterated interaction with the physical machine, just done purely through the lens of software development.
Section 2. The Power of C.
Now, what's really interesting about this slide is the contrast. To interact with hardware exactly the way Torvalds wants, you need the absolute right tool. And for Linux, that is undeniably the C programming language. When he's asked if he follows any other new programming languages for operating system development, Torvalds' famously stubborn answer is essentially no. While a lot of high-level languages intentionally abstract you away from the hardware to make general coding easier, C gives you a predictable, crystal-clear view of the assembly language output. In Torvalds' view, no other language comes even close to C in this respect. It lets you generate truly good, highly efficient code specifically tailored for the hardware.
Section 3. Thinking like a computer.
But listen, this goes way deeper than just generating efficient code, okay? It's really about matching the programmer's cognitive process. Torvalds puts it perfectly. If you think like a computer, writing C actually makes sense. C is literally the ultimate bridge here. For someone whose primary goal is to speak directly and efficiently to the hardware, C is just the perfect medium. Why? Because its structure flawlessly mirrors the logic and the behavior of the machine itself. It completely removes that awkward translation barrier between human intent and computer execution.
Think about the historical context for just a second. C was designed during an era when compilers simply had to be simple. Because of that historical limitation, the language is fundamentally geared toward its output. When Torvalds sits down and reads C code, he basically sees the matrix. He sees the assembly matrix. He knows exactly what the resulting assembly language is going to look like. And that level of predictability, that absolute transparency, that is something he cares about deeply.
Section 4. The Art of Micro-Optimization.
All right, let's zoom in from the language level right down to the microscopic, granular level of coding. If you look at Torvalds' recent Git history over the last few months, you'll see he still gets extremely hands-on. He obsesses over cache misses and file and path lookups. Now, you all know how absolutely brutal fetching from main memory is compared to L1 cache, right? But Torvalds takes it to another level. He literally worries about single instructions. At his level of the game, every single micro delay is the enemy. So, the crucial point is this. Software Engineering 101 literally says, do not micro-optimize, but Torvalds deliberately breaks this rule. His workflow, however, is very carefully calculated to break it safely. Step 1, you absolutely must ensure your fundamental algorithms are completely solid before you do anything else. Only then do you move to Step 2, diving deep into the micro-optimization of those single cache misses. You build the rock-solid foundation first, and then you obsess over that final millimeter of performance. And honestly, he is entirely unapologetic about this meticulous work. As he puts it, if what you love is micro-optimization, that's what you should do. He genuinely finds deep, deep satisfaction in perfecting the smallest, most invisible gears of the machine. It's a proudly contrarian stance for sure, but it's one that continues to pay massive dividends.
Section 5. 1,000 CPUs unlocked.
So what is the ultimate payoff for agonizing over a single, tiny cache miss? What happens when you apply this incredibly microscopic attention to detail at a massive global scale? Well, 1,000. That is the staggering number of CPUs we are talking about here. Over the last 18 months, by focusing intensely on the C code for file and path lookups, Torvalds and his team minimized those cache misses so perfectly that Linux can now perform path name lookups in parallel on a 1,000 CPU machine with absolutely zero contention. I mean, no way, right? It scales flawlessly.
And this brilliantly illustrates the real-world impact. Because of this relentless microscopic optimization, Linux looks up path names faster than anybody else, period. And Torvalds guarantees it. This isn't just about shaving off a fraction of a millisecond just for the sake of it. This fundamentally changes the ceiling for modern enterprise hardware. It allows the operating system to be more powerful and efficient than ever before.
Which brings us to a final, pretty provocative thought to leave you with today. As computing continues to scale ever higher into the future, is this old-fashioned art of micro-optimization exactly what we need to avoid hitting a performance wall?